14.3 is verifying trigonometric identities, and basically you need to understand that a trigonometric identity is just an equation that's true for all values of theta. So just a real simple example here. If I had sine of theta equaled 1/2, you would figure out what theta would equal, or which sine, which angle in degrees or radians has a sine value of 1/2. And that is technically an identity. However, they're going to get a little bit more tricky. These are all the identities that you're going to use. You do not have to memorize them, although you do know probably half of them already. So reciprocal identities, this should look very familiar to you, like cosecant is 1 divided by sine of theta. Secant of theta is 1 over cosine. Cotangent is 1 over tangent. Tangent of theta is sine over cosine, and then because cotangent and tangent are reciprocals, cotangent would be the reciprocal, so cosine over sine. Those are all ones you know. Then ones that you're going to use that you probably weren't aware of is the Pythagorean identities. So sine squared theta plus cosine squared theta equals 1. And I just want you to think about that. Let's just take an angle that we're real familiar with. Let's do 45 degrees. So off to the side here. If I do sine squared of theta, well, if I know that I'm going to use this Pythagorean identity right here. So I know theta is 45 degrees. Well, I know that the sine of 45 degrees is square root of 2 over 2. But then I'm going to square it. So square root of 2 over 2 squared, if I take that point and square it, right, because it's sine squared, that would be 2/4, which is 1/2. Okay, well then you know that cosine of 45 degrees is also the square root of 2 over 2, and if I square that, I get 1/2. So that means 1/2 plus 1/2, sure enough, equals 1. So I want you to understand that while these look like crazy hard or something like that, they're actually just statements that are true. So stick any theta you want in there, and you're going to always, whatever, when you simplify and square things and add them together, you're always going to get 1. Now I won't do that with every single identity, but 1 plus tangent squared theta equals secant squared theta. 1 plus cotangent squared equals cosecant squared. And again, you do not have to memorize any of these. And then last but not least, cofunction identities. It says take sine of pi halves minus any angle, and you're going to have the cosine of that angle. So again, if you just, well, now we're in radians here, so let's just pick a easy, well, let's just say theta is, we'll just say pi over 4. Whoops, why did I write pi there? Let's say theta is pi over 4. So if I'm doing this one, if I take pi halves minus pi over 4, then you know that you'll have the sign of pi fourths. So again, 1/2 minus 1/4 is 1/4, and you know the sign of pi over 4 is square root of 2 over 2, and you also know the cosine of theta is square root of 2 over 2. So that's just cool. Same thing here, cosine of pi halves minus theta equals the sine of pi halves, and you can test it with that again if you want to play around with these. Tangent of pi halves minus theta equals the cotangent of that angle. And then the negative angles just says sine of negative theta equals a negative sine of theta. So again, I'm just going to go with this theta here. So if I do the sine of negative pi over 4, okay, then envision your unit circle. Negative pi over 4 would be clockwise, and the sine value there is negative square root of 2 over 2. Well, if I do here sine of pi over 4, that's a square root of 2 over 2, and then the negative in front of it will negate it. So they're equal, both negative square root of 2 over 2. And then, again, I won't talk through these, but cosine of negative angles equal the positive cosine of the angle, and tangent of the negative angle, equals the negative tangent of that angle. So sine and tangent are similar in that fashion. It kind of goes back to when you inverse, find the inverse of sine and tangent angles. All right, so you're going to be using these properties really for more than what this example is going to show. So I'm going to actually show you how to go through this example using the trig properties, identities. However, then I'm going to go back to geometry and kind of make sure it makes sense, because to me I actually think the geometric way is easier. But this says given cosine of theta equals -3/4, so nothing on our unit circle, and theta is between pi and 3/2 pi, find the value of the other 5 trigonometric functions of theta. Okay, so kind of, you're familiar with figuring all this stuff out. So I'm going to, over to the right here, okay, so first of all, I know cosine of theta equals -3/4. So if I go over here, none of these I have to memorize, but maybe I will take a peek at the Pythagorean identity, sine squared theta plus cosine equals 1. Well, if I know the cosine of theta, because that was given to me in my problem, I could solve this using some algebra to figure out sine. So I'm going to go that route. Okay, and I just wanted to kind of make sure you understood where I was getting this. And again, quite honestly, this isn't the easiest route. But if I do sine squared theta plus cosine squared theta equals 1, because that's an identity, well, I know that cosine theta equals -3/4, so that's really going to be -3/4 squared in replace of cosine squared. And that just didn't write very nice. There we go. And sine squared theta I can solve for. So -3/4 squared, I'm going to talk through some math in my head here. -3/4 squared is 9/16, and then I'm going to subtract that over. This will turn into a positive 9/16, so I'll subtract over 9/16, which is that, right? So 1 minus 9/16 is 7/16, because 1 is 16/16, right, if you want to change that to 16/16. And then I square root both sides, and I'll get sine theta equals the square root of 7 over 4, because when I square root 7, that's just square root of 7. When I square root 16, that's 4. And now I know what sine of theta is. Now, to me, that's actually pretty slick. But the problem is you have to think about, you're in the third quadrant, right? So in the third quadrant, you know that your x and y values are negative, right? Negative and negative, and of course your hypotenuse is going to be positive. So I know that my sine value is really going to be negative. Okay, well, once I know my cosine is -3/4, I guess I could fill that in right here, right? I know the secant is the reciprocal, so that's -4/3. Once I know sine, I can reciprocal that. Now, when I reciprocal that, I have to rationalize, right? And I think you're okay with rationalizing. So that's going to be -4 root 7 over 7. And tangent is sine divided by cosine, which you know. So I'm going to take my sine value and divide, or actually I'll multiply by the reciprocal of cosine. So I'm going to take my sine divided by cosine, right, to get tangent. So that's negative square root of 7/4 times the reciprocal of -3/4. My 4's cancel out, and the negatives cancel out, and I get the square root of 7 over 3. And then if I reciprocal the tangent to get the cotangent, again, when I reciprocal that, I'm going to have to rationalize, and you can do that math at this point. So that's going to be 3 root 7 over 7. And that is how you do it using the trig identities. Now I'm going to take this same problem and just work it out geometrically, and I'll go through that a little bit quicker here. Alright, so cosine theta equaled -3/4. And we knew, or were told, that theta had to be between pi and 3/2 pi. Okay, so if I draw my angle here and connect it to the origin always, and there's theta always at the origin, I know that cosine is adjacent over hypotenuse. So my adjacent would be here, and my hypotenuse obviously over here. While I know here my adjacent then is the -3, and my hypotenuse is the 4. So that means this is -3, and this is 4. Okay, now I could use Pythagorean Theorem. A squared plus b squared equals c squared, so that's going to be 9 plus b squared equals 16. Subtract 9 and I get 7. Take the square root and I'm going to get plus or minus 7. And I know, because it's going down here, that it's the negative square root of 7. So to me, geometrically speaking, actually it's just as easy. You can kind of decide what you like best. So now I can figure out every angle, and I won't go through them all because I just talked about that. But sine, of course, is opposite over hypotenuse, so you get negative root 7 over 4, and that's what we got using the trig identities. And then, of course, you reciprocal that to get the cosecant, and I won't talk about that again, but tangent of theta, you know, is opposite over adjacent, so negative square root of 7 over negative 3, and those negatives cancel out. So again, and you know, et cetera, and I won't finish it off, but I just want you to understand that for sure you can do this problem algebraically, or algebraically using your geometry skills also.